Hi, welcome to Math 1300, Nunez Community College. This is section 7.4, which is first degree inequalities. In these inequalities, we're going to be solving and graphing them. We're going to look at sets of numbers. First of all, the set is going to be designated with a capital letter. We'll have braces, and we'll have numbers separated by commas. So if I have 1, 2, 3, 4, this is the set of numbers that are positive numbers that are less than 5, okay? If a set has nothing in it, then it's going to be called a null set, and a null set is usually written with a circle with a line through it. This is the null set, otherwise known as the empty set. Another way of writing empty set is with the braces with nothing in it. If we want to look at two sets and we want to look at the combination of them, we have something called a union or an intersection. Suppose I have set A, which is this one here, between 1 and 4, and suppose I have set B, and in set B, we're going to have 3, 4, 5, and 6. 3, 4, 5, and 6. Okay? We may want to look at A with a U and B. This symbol means union. And union means including everything that belongs in either set. Everything that belongs in either set. So A union B is going to be, well, there's a 1, there's a 2, there's 3 and 4. And then in B, we have a 3, we already have a 3, we have a 4, we already have a 4, but we also can add 5 and 6. So the union of sets A and B would be everything that you see in both of them not repeating. This is called a union. We also have another term called an intersection. That one is an upside down U. This is called the intersection of sets A and B. The intersection means only what's in common with both. Only what's in common with both. Well, in set A, I have a 1, but no 1 in set B. In set A, I have a 2, but no 2 in set B. However, I have a 3, I also have a 3 in set B, so 3 would be part of the intersection. I have a 4, I also have a 4 in set B, so that would be part of the intersection. There are no more numbers in set A, so therefore this would be the intersection of A and B. We have a couple of terms that we have to look at when writing these things. One is going to be a sideways 8. This sideways 8 is known as infinity. Infinity. Infinity is a number that we try to reach if we're going higher and higher and higher. Well, infinity never is actually reached because no matter what number you can come up with, we can always add 1 to it. And on the opposite end of the spectrum, we have negative infinity. Negative infinity. These are used when working with numbers on a number line. On a number line, we have 0, and we have the positive counting numbers to the right, and we have the negative counting numbers to the left. Well, if we go all the way to this arrow, we'll consider this negative infinity. And if we're going all the way to the arrow to the right, we'll consider that positive infinity. So negative infinity and positive infinity is used if it keeps going and going one direction or the other. in one direction or the other. Now, in order to talk about these sets, we have sets with the numbers in here, but how many numbers do we put before we try to label it a different way? Because I don't want to write a set and have to write, 30, 40 numbers inside the set unless I have to.
Bayshon Stackhouse, please report to the front office.
So one thing that we have is something called a set builder notation. Set builder notation. In set builder notation, there's a bracket and an X and a line and an X. And we may have something like this. This means greater than. This is read as X such that X would be greater than 0. X such that X would be greater than 0. Well, if I try to write that using the other notation, greater than 0, if we're talking about integers, would be what? 1, 2, 3, 4. But the thing is, it never stops. It keeps going. So if we write this using set builder notation, it's a lot easier to write than to keep on putting numbers in. Okay? So this is another way of writing a set. It's called set builder notation, and it's read as X such that X is, and then something. Greater than 0, less than 0, greater than a number. Another way of writing is called interval notation. And interval notation kind of works off of what it would look like on a number line. Interval notation would be with parentheses or with brackets or with a combination of them. With interval notation, they literally have the number you start at and the number you finish with. If I wanted to write this one here using interval notation, we know that it's got to be greater than 0. So I would write 0, and the number that we represent being greater than 0 would be all the way to as much as we can think of, which would be the infinity symbol. Okay? Since it's greater than 0, what is the difference in this? This is greater than or less than. We use a parentheses. This with the bracket is greater than or equal to. If it's actually equal to that number, we'll use a bracket. If it's just greater than, we use a parenthesis. Or less than or equal to. As we can see here, we just used greater than. So since greater than is a parenthesis, we would use a parenthesis on the left. And we never actually get to infinity, as I said before, because no matter what number you think of, we can add a number to it. So that would be a parenthesis on the right. This would be the interval notation of that. So this would be in set builder notation. This would be in interval notation. They both represent the same exact number. They both represent the same exact number. For example number 1, they're going to want us to write it from set builder to interval. So exactly like we just did on that one. So they're going to want us to write it from set builder to interval. So write in interval notation. I'm going to have X such that X is greater than or equal to 2. X such that X is greater than or equal to 2. Set builder, they want us to write it in interval. So greater than means 3, 4, 5, and so on and so on. So we would start with 2. And greater than means we keep on going, so we'd end up with infinity. So from 2 to infinity. This time though, it says greater than or equal to, so instead of having a parenthesis, we would have a bracket. We never, ever, ever hit infinity, so infinity and negative infinity always has a parenthesis. Always has a parenthesis. Another way of doing a set builder, if we start with a number instead of starting with or ending with an infinity, we could say something like this. Take it from set builder, x such that x, actually not x such that 0 is less than x, which is less than or equal to 4. That means the numbers from 0 to 4, not including 0, but including 4. How are we going to write that using interval notation? We would have 0 to 4, start and finish, not including, so parenthesis, including, so bracket. That would be my interval. Okay, we now are going to go the opposite way. We're going to take it from interval notation and rewrite it using set builder notation. So interval and set builder. So for this one here, we're going to start out with negative infinity, comma 0. And we want to write it using set builder. So what is this going to be? Braces, x such that, what is this? From 0 to negative infinity, or from negative infinity to 0 means what? It's less than or equal to 0. So this is going to be x is less than or equal to 0. Okay, suppose we have negative 3 to 3, parenthesis, parenthesis. Negative 3 to 3, parenthesis, parenthesis. This will be braces, x such that, well, we're not going all the way to negative infinity or infinity. We have our two numbers, so it's going to be negative 3 is less than x, which is less than 3. Braces. Okay, now they want us to graph these things. Well, how are we going to graph these things? They're going to be graphed on a number line. They're going to be graphed on a number line. So it says graph negative infinity to 5. Negative infinity to 5. So it's going to be on a number line. We know that this is a 0, which is kind of what we say is our middle, even though a line has no middle. We'll start off with 5, because that's our point that we're going to either start or stop at. And would we go into negative infinity? We established that negative infinity was to the left. Since it's not equal to 5, there's already a parenthesis here. So we would put a parenthesis at 5. And we're going to actually have it facing the side that we're going to shade to. And then we're going to shade this all the way to the arrow itself. Shade it all the way to the arrow itself. Okay, they now want us to graph one that's in set builder notation. So graph, if we have x such that negative 2 is less than x, which is less than or equal to 1. We'll have a number line. My numbers will be 0. I got negative 2 and positive 1. So we put them on respective sides of 0, like it says. And what do we know? We know that it's greater than negative 2. So since it's greater than, it's going to go to the right. So it's going to be opening to the right with a parenthesis. And then it's less than or equal to 1, so that's going to be a bracket, and we'll shade inside. We'll shade inside. Okay, now we're going to have to solve the inequality and then graph. So it's a lot like the equations. The same rules apply. It's just instead of having an equal sign, we're going to have an inequality sign. So solve and graph the inequality. X plus 2 is greater than or equal to 4. X plus 2 is greater than or equal to 4. Well, I want x by itself, in this case on the left of the inequality, so I'm going to bring the 2 to the other side. Subtract 2 from both sides, cancel, x is greater than or equal to 2. Once I have this is called the inequality. This is called the inequality, so therefore we got what? 0, we're at 2. It's greater than or equal to 2. Greater than goes to the right. Greater than or equal to would be a bracket and a shade. We'll continue with part B of this lesson at a later time. Thank you.